Chemistry. It is all that matters, and we will continue our discussion talking about scientific notation. One of the most important numbers in chemistry, and one of the numbers that we will be dealing with for the entire year, is a number called Avogadro's number. It is also referred to as the mole. And basically a mole is kind of like a dozen. It's a way of quantifying, giving value to a common amount so everybody talks about the same thing. And in this case, Avogadro's number, and in all cases Avogadro's number, is 6.02 times 10 to the 23rd. Now this is written in scientific notation because the actual number looks like this. 602 followed by 21 more zeros. That's a whole lot of stuff. Now, if we had to write out all these zeros all the time, it would take forever, it would waste paper, waste ink, and we would get quite bored with chemistry. So instead of writing 602 and then 21 more zeros, we will use scientific notation to shorten that to 6.02 times 10 to the 23rd. Now, how do we do that? Well, basically, we start where the decimal would be, which is at the right end of the number, and we start moving that decimal. So we move it 1, 2, 3, 6, 9, 12, 15, 18, 21, maybe 21, and then 23 times. And when we move it 23 times, we are creating 23 positive spaces on the number line, and therefore that is a positive 23 for the value. So that is where we get the number 6.02 times 10 to the 23rd, because we moved that decimal 23 times. But we can also move the decimal for really, really small values. And here we have an example. We have 3, 6, 9, 12, 15, 18 zeros in front of this 78. And this would be a really small number. And what we do is, again, we're going to move the decimal. And we're going to move the decimal 3, 6, 9, 12, 15, 18, 19 times, giving us a value of 7.8 times 10 to the negative 19th, because we're moving to the smaller value, we're moving towards the decimal values, and therefore that becomes negative. So let's look at some more samples of this. So here we have 4.531 times 10 to the 5th. So what we do is we start with our value. We then move our decimal places, and we're going to move our decimal places 5 times. So 1, 2, 3, 4, 5 values. Now what that's going to do is it's going to necessitate that we add some zeros. So when we add the zeros, this number looks like this. And our final value becomes 453,100. So with a positive exponent, move your decimals to the right. So here we have 3.21 times 10 to the negative third. So we're going to take that value and we're going to move the decimal 1, 2, 3 times. Now that is going to necessitate us moving the decimal and adding 2 zeros in front of the 321, which gives us a value of 0.00321. So when the exponent is negative, move your decimal to the left. So in the Sophia, you have this handout as part of a PDF, and you have this handout as part of the PDF. On the first part of the handout, you are to change those values to scientific notation, and on the second half, you are to change those scientific notation to standard notation. So go ahead and print out that PDF. Complete the work, turn off the video now, and then after you complete the work, come back and check how you did. So let's see how you did. So in each of these cases, we have moved the decimal the appropriate number of spaces. So for 3,400, you have to move the decimal 3 places to the left, making it 3.4 times 10 to the third. For 0.000023, you have to move the decimal until it is past the 2, giving you a ones digit, and therefore it becomes 2.3 times 10 to the negative fifth. 101,000 becomes 1.01 times 10 to the fifth. Please check your work and see how you did. Now, go down to number 8, and this one already has the 4 in the ones place, so you don't actually have to move the decimal. So that's why it is 10 to the 0, because remember, anything to the 0 is 1, so 10 to the 0 equals 1, so basically you have 4.50 times 1. So let's check how you did on the multiplication part, where you changed the scientific notation to standard notation. So for 2.30, you move the decimal 4 to the right, giving us 23,000. For 1.76, you move the decimal 2 to the left, which means that you're going to put 2 zeros in front of the 176, giving you 0.00176. Again, let's go down to number 15 and look at number 15, where we have 1.76 times 10 to the 0, and 10 to the 0 equals 1, so that's 1.76 times 1, which gives you 1.76. So hopefully this gave you insight into scientific notation, and if you already knew scientific notation, this was a good practice reminder, and let's continue working on our chemistry.